Alright, so we're going to talk about acceleration this time. The objective for this is that students will be able to recite the equations and related units of measure of objects moving with acceleration. You will need paper and something to write with, and there will be the Edmodo homework quiz. As always, let's begin. So to review, we've already talked about scalars and vectors, speed and velocity, distance and displacement. We've talked about the meaning of slope on a position versus time graph. And we've mentioned stuff about velocity graphs, but not as much. Today we're discussing things that are moving with speeds that are changing instead of constant. This is called acceleration. Where am I? Oh my goodness. Here we go. This equation is average acceleration, not... It only tells us if we know, or we can only calculate the acceleration if we know the velocities and the time. That's it. But we don't always know that stuff. So there's a few other equations we're going to need. And there's a whole lot of different letters in here. The first one, the first symbol in that list there is V with the X and the 0. That's the initial horizontal velocity. The V with the X without the 0, just like displacement was, that's the final velocity. So we have Vx naught and Vx for initial and final velocities. Then there's Ax, which is the horizontal acceleration. A meaning acceleration. X with no subletters, the final position. X with a sub 0 is the initial position. And T is time. Next class we're going to focus on when to use each of these equations depending on the problem. Because there's a whole bunch of different symbols, so it's really important to be able to choose the correct one to use depending on the problem. But that's not something I'm going to have you do here. We'll do that in class. Just make sure you get those equations down and what all those symbols mean there. And these are all on the AP equation sheet that you were given a class or two ago. Units, position, just like before, is in meters. That's the standard unit. Velocity still in meters per second for either the initial or the final velocities. And the units for acceleration are meters per squared second, as previously stated. Time will always be in seconds. And those X subletters next to the velocities and positions, well, not positions, acceleration, next to velocity and acceleration, stand for it being horizontal. We'll later on talk about vertical acceleration, which is gravitational stuff. We'll get there. Right now, just think of it as horizontal stuff. And the book you will be using uses Vf and Vi for final and initial velocities instead of Vx and Vx naught. When we have graphs of velocity versus time, the graph slope would tell us distance over squared time, because you'd have distance on the y-axis and time on the x-axis. So that would give us usually meters per second squared or centimeters per second squared or some type of distance over time squared. And since that's the unit for acceleration, the slope of a velocity time graph tells us acceleration. So in this picture here it says that there are two different cars, A and B, represented by two lines on that graph. And it's asking, is car A or car B the car with the greater acceleration, or are they equal? And since acceleration is represented by the slope of a velocity time graph, that means B has a greater acceleration since it has a steeper line. So that's it for this one. Be sure to go on to Edmodo and take the homework quiz. And make sure to bring your bring your notes with you to class next time to take the in-class note quiz, which won't always be exactly copy and pasted from Edmodo, I promise. Thanks again, and goodbye.